All right, so in the next part of this unit where we're solving triangles, we're going to get into something called trigonometry. And what trigonometry is, it's all about the study of the relationship between the angles and the sides of a right-angled triangle. So all our triangles are going to have a right angle, and to show that, we put a little box there, and what a right angle actually means is that you have a 90-degree angle in your triangle. So that's all we're going to deal with is triangles with 90 degrees in them. All right, now, hopefully you know this with a triangle, but there is 3 sides to a triangle, all right? Now, in trigonometry, they all have a name, actually. Now, the first one is the one that is across from the right angle. It's always across from the right angle, and that is what we call our hypotenuse. Now, that is something we talked about when we dealt with the Pythagorean theorem that we looked at. What do we have when we deal with a right angle triangle? Well, again, the side across from the right angle is always called the hypotenuse. Now, here's the thing with trigonometry is because you're dealing with the angles and the sides, you look at one of the angles. You're going to use one of the other angles. Never the right angle, but you're going to look at one of the other angles. So I'm going to say we're looking from this particular angle. And I see I got a circle there with a line through it, and that's called theta. It's a Greek letter. It's just used to say that, or look, when we're looking for an angle, we use theta. Just like when we're looking for a side, we always use X or Y. With angles, usually use a Greek letter. Not sure why. Now, from that other angle, which again, I'm just going to put that down, that theta is just some angle that we're looking from. Now, across from that angle, that particular angle, that is called your opposite. So that is the side across from your angle that you're looking from, theta. The third side, because as I mentioned, triangles got 3 sides, is the side beside the angle. Now, they use a fancy word, and this is what I struggled because when I was in high school, I wasn't very good with English. Another word for beside is adjacent. So we have our 3 sides. The hypotenuse is across from the right angle. The opposite is across from the angle we're looking from. And the adjacent is the side beside that angle. All right, now, what we're going to look at in this first class is that there are 3 trigonometric ratios to know. So put a little ratios in there. Now, as we looked at earlier in this unit, ratios, when we dealt with ratios, can also be expressed as fractions, and that's what we're going to do. Now, these 3 trig fractions, or ratios, are called sine, cosine, and tan. Now, what the sine is this, if we look, now I'm going to leave a space here because I'm going to show you something, how to remember these fractions. The sine, we write sin, and you might have seen this on your calculator, theta. And so what that ratio is saying is, what sides are we going to divide when looking from this angle? And the sine ratio is when you take the opposite side and you divide it by whatever number the hypotenuse is. So that is the sine ratio, again, as a fraction. Take the opposite and divide it by the hypotenuse. The other one is our cos ratio. And that is when you take the adjacent side and you divide it by the hypotenuse. All right, and then the last one is our tan ratio. And our tan ratio, so we go tan theta because the theta tells you which angle you're looking from, and the tan tells you which ratio. And the tan ratio is the opposite side divided by the adjacent. Now, you have to remember these three ratios, but I have a little trick to remember them. I use little phrases. And for the sine ratio, what I use is the phrase sine on highway. Because later on today, you have to be able to memorize and figure out what ratio we're going to use. And so the sine ratio, what I look at is the letters in front of each word. So the sine ratio is when I take the O, opposite, and I divide it by the H, the hypotenuse. All right, now the cos ratio, to remember that the cos ratio is the adjacent divided by the hypotenuse, I use the phrase cozy at home. All right, and so that is the cosine ratio. See the A, the adjacent divided by the hypotenuse. And the last one, not so much for me because I'm Irish, but the tan ratio. Again, how do I memorize the tan ratio? Is the opposite side divided by the adjacent? Tan on arms. The tan ratio is the opposite divided by the adjacent. All right, so we have my three phrases to remember my three trigonometric ratios. Sine on highway, cozy at home, tan on arms. Now, how am I going to use those? That's what we're getting to next. All right, so flip my board. All right, so for example 1. Given the following triangle, so I'm going to draw out a triangle here. So here we are. And since we're doing trig ratios, it has to be a right angle. So I'll put my little box in there. I'm going to say that this is angle A over here. This is angle B. And this is angle C. And I'm going to say this side is 13. This one here is 12. And this one here is 5. And I want to find, first off, I'm going to find A, sine A, B, sine, whoops, cos, I got to use my other ratio here, cos A, and C, tan A. So I want to find those ratios. All right. Now, and then we're going to do a DEF here. So I'm just going to leave that for now. We'll just put that here, but we'll get to that. Now, I'm going to explain how to find these ratios. The sine ratio, sine of A. So first of all, the A is telling us this is our angle we're looking for, our theta, if you will. That's our perspective. We're looking from that angle. Now, when I'm looking for sine, I'm going to take two sides and divide them. I got to figure out which side I'm going to divide by which. And again, that's where I come back to my phrases. Sine on highway, cozy at home, tan on arms. So if I'm looking for the sine ratio, sine on highway. On refers to the opposite side. Highway refers to the hypotenuse. All right. So now I know which sides that I'm going to divide. The key here now is to find those sides. I have my triangle here. Now again, to start off, the easiest one, I guess, is the hypotenuse. The hypotenuse is always the side across from my right angle. And in this case, it is 13. So I put a 13 in the bottom because that's the hypotenuse. The opposite side. The opposite is always across from the angle you're looking from. Well, here's our angle A that we're looking from, and if I go across from it, I have a 5. So the sine A ratio, which again, a ratio, we looked at this before, can always be expressed as a fraction, is 5 divided by 13. That's our sine ratio. All right, now we get to the next one, cos A. So again, I'm going to take two sides and divide them. All right, now it's which two sides am I going to divide? And again, this is where I use my phrases. I don't use sine on highway, but I am going to use cozy at home. Cozy at home. At refers to the adjacent. Home, again, refers to the hypotenuse. Now, I look at my ratios and I know which sides I'm trying to find or which ones I'm dividing. And so again, my hypotenuse here is across from the right angle. It's still 13. The adjacent, though, is the side that is beside angle A. Now, watch this. I go to angle A. There's actually two sides that are beside angle A. But guess what? The 13 is the hypotenuse. So the only one to pick is the 12. So the hypotenuse is always the hypotenuse. All right, so the other angle, or the other side that's beside our angle here was 12. All right, now the last, well, not the last one, tan A. So again, I'm looking from angle A. And now I have to figure out which sides I'm going to divide. All right, and so I look at it. Again, my phrases, sine on highway is no good to me. Cozy at home is no good to me. Tan on arms. On arms. On, opposite. Arms represents adjacent. So now I got to take the opposite side and divide it by the adjacent. Well, again, I look at my diagram. The opposite is across from the angle we're looking at. That's a 5. All right, the adjacent. Well, we looked at that already, the side beside our angle. I already know my 13 is my hypotenuse, so my 12, again, is my adjacent. And so my tan A ratio is 5 divided by 12. Now, I got a DEF. I'm going to find the sine of angle C, the cos of angle C, and the tan of angle C. All right, so now I'm not looking from angle A. All of these, I'm looking from angle C. So I'm going to erase this. All right, so again, we're looking from angle C. So there's my theta. It's the angle I'm looking from. Now again, doing the same thing with those memory phrases. Sine on highway, cozy at home, tan on arms. Sine C, sine on highway. We have our opposite divided by our hypotenuse. Okay, now, again, the hypotenuse always across from the right angle. So it is a 13 in the bottom here of my fraction. Now the opposite. The opposite is opposite across from the angle we're looking from. Well, we're looking from angle C this time. So I go across. And 12 is now my opposite. And there we go. So our sine C ratio is 12 divided by 13. Cozy at home here. We got the cosine of angle C. So again, cozy at home, at adjacent, home, hypotenuse. Okay, so, well, the hypotenuse is in the bottom. The hypotenuse is not changing. It's always across from the right angle. So I put that in here. Down the bottom, 13. But now I got to find the adjacent. So again, I'm looking at my diagram here. The adjacent is the side beside our angle we're looking from. Well, I got two sides again, a 13 and a 5. But again, the 13 is a hypotenuse. So 5 has to be our adjacent. So our cos C ratio is 5 divided by 13. All right, now our last one, tan C. Again, tan on arms. On is the opposite. Arms represents the adjacent. All right, so now when I find the opposite, okay, so again, we're looking from angle C. Across from that angle is a 12. That's our opposite. And now we found this last time. What side is beside our theta that's not the hypotenuse? Well, it is our 5. And so our tan C ratio is 12 divided by 5. Now, something I want you to notice. Look at sine A, which is 5 divided by 13, and sine C, which is 12 divided by 13. So because we're looking from a different angle, we get a different fraction. The same thing with cos A and cos C. 5 divided by 13, 12 divided by 13. We're looking from a different angle, so we're getting a different fraction. Same thing with tan. 5 over 12, tan A, and tan C, 12 over 5. The one thing that is consistent with all of these is that our hypotenuse is always across from our right angle. And the other thing is that I found sine A, cos A, tan A, sine C, cos C, tan C. The one thing I couldn't find, or the 3 things I couldn't find, was sine B, cos B, and tan B, because you never look from your right angle. It's either the angle in the bottom or the angle in the top is how we find our ratios. Never across from the right angle. And that is finding our basic trig ratios, which again, a trig ratio, a ratio in general,